Namaste everyone and welcome back to our channel. Today, we are diving into a super important topic in Java programming, Java memory management and garbage collection. Don't worry, it sounds complex, but I promise you, by the end of this video, you will understand perfectly how Java handles its memory and keeps your programs running smoothly. We will learn what memory management is, why it is crucial for efficient Java applications, and how Java's automatic garbage collector works behind the scenes to clean up unused memory. This knowledge is fundamental for every aspiring Java developer, so let's get started with our first scene. Alright, my dear friends, let's begin by understanding where our Java program's data lives in memory. Java primarily uses two main areas for memory, the stack and the heap. Think of the stack like a neatly organized pile of plates. When you call a method, a new plate, called a stack frame, is added to the top. This stack frame holds local variables, primitive data types like integers and booleans, and references to objects. When the method finishes, its stack frame is removed. The heap, on the other hand, is like a big, open warehouse. This is where all the objects you create using the new keyword are stored. Objects can be of any size, and can be accessed from anywhere in your program as long as you have a reference to them. So, primitive values and method calls go on the stack, and all your objects go on the heap. Very important distinction, isn't it? Now that we know about the stack and the heap, let's talk about the hero of our story, garbage collection. In languages like C++, you have to manually allocate and deallocate memory, which can be quite error-prone. But Java, my friends, is smarter. It has an automatic process called garbage collection. The garbage collector's job is to automatically identify and remove objects from the heap that are no longer being used by your program. How does it know an object is no longer used? Simple. If there are no active references pointing to an object, it means your program cannot reach or use that object anymore. Such objects are considered garbage and become eligible for collection. When the garbage collector runs, it reclaims the memory occupied by these unreachable objects, making it available for new objects. This prevents memory leaks and makes programming much easier for us. Let's see this in action with a simple Java code example. Here, we create a class called myObject. In our main method, we first create an instance of myObject and assign it to a reference variable obj1. This object is now alive on the heap. Then, we create another myObject and assign it to obj2. Now, both objects are active. What happens if we set obj1 is equal to null? The object that obj1 was pointing to no longer has any active references pointing to it. It becomes unreachable and is now eligible for garbage collection. Similarly, if obj2 goes out of scope, or we reassign it, its object might also become eligible. We explicitly suggest to the garbage collector that it might be a good time to run using system.gc, but remember, this is just a suggestion. Java decides when to actually run it. This shows the entire life cycle, creation, use, and then becoming eligible for cleanup. My dear students, while Java's garbage collector is fantastic, it's essential to be aware of some common mistakes that can lead to inefficient memory usage, even if not outright memory leaks. A common mistake is holding on to unnecessary object references for too long. For instance, if you add many objects to a static array list and never remove them, those objects will never become eligible for garbage collection, even if your program logic no longer needs them. Another pitfall is forgetting to close resources like file input-output streams or database connections. These can hold on to native memory or system resources, not just Java heap memory, and must be explicitly closed. The best practice is to always ensure that objects you no longer need have their references set to null or go out of scope, and always close your resources using private resources statements to ensure proper cleanup. Remember, good memory hygiene leads to robust applications. And there you have it, my friends. In this tutorial, we have covered the fundamentals of Java memory management and garbage collection. We learned about the stack and heap memory areas, understood how Java automatically identifies and reclaims unused memory through its garbage collector, and saw a practical example of object lifecycle. We also discussed common mistakes and best practices to write more memory-efficient Java code. Understanding these concepts is a powerful step towards becoming a proficient Java developer. Keep practicing, keep coding, and remember to apply what you have learned. If you found this video helpful, please give it a big thumbs up, share it with your friends, and do not forget to subscribe to our channel for more exciting Java tutorials. Happy coding, and I will see you in the next video. Jai Hind.